everyone, my name is Akriti Gupta and today I am giving a demo lecture of physics. The topic I have choose is electricity. So first, before starting the chapter, let's have some basic idea which we have already studied and let's connect that thing to our main chapter. So in the first chapter of class 12, we had already studied about charges. So charge is nothing but it is the intrinsic property of a substance due to which it gets deflected in electric and magnetic field. Also, we had studied about the properties of charges like like charges repel, unlike charges attract, quantization of charges, additive property, conservation of charge, and so on. So the main motive to start with this charge is that I will put two cases on this charge. The first case is that when the charge is at rest, that means the velocity or the speed of the charge is zero. At that time, we call it as electrostatistics. This thing you have already studied in first and second chapter of class 12. The second case is when charge is in motion. That means the velocity attained by a charge is non-zero. So in this case, in the second case, we call it as electricity. So we have started from charge. We have imposed two conditions on charge. One is at rest, another is in motion. And from that we connect to our chapter electricity. That means in this chapter we will study about the charges which are in motion. Now, what is our main target is to understand what is the thing that causes this charge to move from one place to another, and that thing is potential. So let's define potential first. It is the work done by a charge to bring a unit positive test charge from infinity at a point in its field of influence. So before moving to the actual definition, let's understand about the few terms which we had used here. First one is the unit positive charge. Unit positive charge. So unit positive charge means the magnitude of the charge is 1 coulomb and the polarity on the charge is positive. Another thing is the field of influence. Let's take an example like we have a heater. As we move towards the heater, we will experience the warmth of the heater more and more. As we go away from the heater, we experience the warmth of the heater to a lesser extent. That means there is a certain region around the heater up to which you can experience the heat of the or the warmth of that heater. So similarly, there is a charge, consider a charge in place of a heater, and that charge also has its own field up to which you can experience, not you, basically another charge can experience a force of attraction or repulsion or its electric field in its vicinity. So that is its field of influence. Now, there is this charge q and there is another charge small q. The distance between these two charges is infinity. What does this mean is that the small q charge is not in the influence of this capital Q charge. That means potential at this point. The point, say let's name it as B and this let's name it as A. So at point B where this small q charge is there, the potential at that point due to capital Q charge is 0 because it is at infinite distance. Okay, so now this charge wants to bring this capital Q charge in its field of influence, and for this it will do some work. So the formula for potential becomes work done per unit charge. So it is the work done by a charge to bring a unit positive charge from infinity to its field of influence. It's a theoretical concept. Now let's talk whether it's a scalar or a vector quantity. So it's a scalar quantity, and if we want to talk about its unit, then its unit is volt. Or another unit will be joule per coulomb. Why joule per coulomb? Because the unit of work done is joule and the unit of charge is coulomb. That's why joule per coulomb. Now the next topic which we will study is potential difference. Now you might have questioned that we have already discussed about potential, then what is the need to study about this potential difference? This is because this concept of potential is hypothetical and the distance between the two charges is at infinity. But in real application, whatever conductors we have in our house, that is of finite length or finite distance. Okay. So suppose there is one conductor and there are the two terminals of the conductor. This is the terminal A and this is the terminal B. And suppose the charge is moving from B to A. So here the potential will be VA and here the potential will be VB. In the previous case, what we had Q and small q. The potential at this point is 0 and the potential at this point is V. So even if we take the difference of the potential between the two, what we get? V minus 0, which is V. That is nothing but the potential of capital Q charge. Now here the potential at both this point, they have some finite potential. So we have to deal with potential difference. So we can write potential difference as VA minus VB. That means the difference of potential at point A minus difference of minus potential at point B. So how can we define it as this potential difference as it is the difference of potential between two ends or terminal of a conductor. And similarly, as it is a difference of potential only, its unit is volt. Another thing, the instrument which we use to measure the potential difference is voltmeter. Voltmeter is the instrument used to measure the potential difference. Now, the next topic is drift velocity. Now, here it is one conductor and I had applied an electric field across it. As I applied the electric field, let's the direction of applied electric field is this one. In a normal case, in any conductor, the electrons are in random motion. Okay? Suppose there is any conductor And here are these electrons, and these electrons are in random motion. So the net or the overall velocity is of the electrons is zero. That's why there is no current in the conductor. But as soon as I apply the electric field, there will be a creation of some potential difference and the electrons move in a particular direction. And that direction is opposite to the electric field. So now all the free electrons are moving in the same direction. So we can say that drift velocity is the velocity with which free electrons of a conductor drift towards the opposite direction of the electric field. So here what we said that it is in the opposite direction of the electric field. Let's verify how. We can write force on electron as minus E into capital E, where E is the electronic charge and capital E is the electric field and F is the force on electron. Another thing which we can write is force is nothing but mass into acceleration from Newton's second law. And here we are taking the mass of electron. In case of electron, we will take me, or in generally what we can write as m also. Now from the equation of motion, we know v is equal to u plus a t, where v is the final velocity, u is the initial velocity, a is the acceleration and t is the time. Here we take t as relaxation time. Relaxation time or mean free time. What does this mean is that between the two successive collision, it is the average time, okay? Suppose this is electron number 1. This electron 1 gets collided with this another electron. This electron 2 might get collided with electron 3. This electron 3 might get collided with electron 4. So the average time for which these electrons are being collided is known as relaxation time or mean free time. So now from here what we do, V is equal to u will be 0 plus acceleration. What we get, acceleration is minus E by m here. So I will write here is minus E by m. The vector sign and this velocity becomes Vd, and here what we have tau. Instead of t we will have tau. So Vd is equal to minus E by m. Now see, what you have in the expression is the negative sign. This negative sign signifies that the direction of drift velocity is opposite to the direction of the electric field, and this is the formula for the drift velocity. If you want to write its magnitude, then what can you do? You can put it in more. So it will be E tau by m. One more thing what we have here is Vd is inversely proportional to mass. So more the mass, less will be the drift velocity. So if anyone asks you whether electron have more drift velocity or the proton, what will be your answer? The answer will be the one which has less mass. Among electron and proton, which will have less mass? Electrons have less mass, 9.1 into 10 to the power minus 31 kg, and this will have 1.67 into 10 to the power minus 27 kg. This means that the drift velocity of electron is more than that of the drift velocity of proton. So, thank you. That's my lecture.